Hello everyone, this is Mrs. Tipti Kulkarni, lecturer, Department of Physics, KLS Kokte PU College, Belgavi. In continuation with my earlier video on first chapter Physical World, this is my third lecture from the same chapter. In this video, I am going to discuss few more concepts from the physical world. Let us begin with physics for society. How physics is beneficial to the society. Okay, so based on the physics concepts, there are so many facilities or the instruments, home appliances, whatever we are enjoying today, or we can say that transportation. So all we are enjoying because of what? Because of physics concepts. Okay, so here I had taken few examples like aeroplane, okay, which travels, of course it is a faster, and we enjoy colored television, or we can say refrigerator. All these are home appliances. Computers, we are using computers, we are using the mobile phones, wireless communication, we are using laptops, okay. Then we are using some current, based on current electricity, okay, or based on current, we are using so many electrical appliances, okay. So all these are what? These are helpful, okay, so to the society. So in our, to lead our day to day life, we need all these facilities, and all these facilities are gifted by physics. Next one, fundamental forces in nature. There are basically 4 different types of forces. I think you might have studied in school level about these forces. Okay, so first one, gravitational force. We also already we discussed about this gravitational force in the previous videos. Okay, second one, electromagnetic force. Third one, strong nuclear force. Fourth one, weak nuclear force. Let us study one by one in detail. First one, gravitational force. It is the force of attraction between any two particles in the universe. Okay, it is the force between what? Between the two particles. Suppose if we consider two particles here, we don't know what are their masses. So I will assume here the masses of those two particles m1 and m2. M is the notation for the mass. So for the first particle, mass is denoted by m1, for second particle mass is denoted by m2. Both are separated by certain distance. Okay, that distance how much we don't know, so we denote by, suppose if we denote by r, then how we have to write the force formula? According to the Newton, force is denoted by F notation. Okay, so force is denoted by what? F notation, directly proportional to m1 m2, okay, and inversely proportional to the square of the distance between them, right? Then if we remove this proportionality, then we have to add some constant value instead of that proportionality sign to equate that force. Therefore F is equal to G into m1 m2 upon r square. So this is that expression. F is equal to G into m1 m2 divided by r square. This is also same. Okay, so F is a gravitational force, m1 m2 are the two masses here, r is the distance between the two particles. Okay, so this is one example. Same type of formula here given, and this is a well known story, apple story of Newton. Okay, so which shows the gravitational force, okay, force between the earth and the this. Okay, So this is about gravitational force. It is the force of attraction between any two particles in the universe. It is the weakest force in the nature. This is very very important. Gravitational force is the weakest force in the nature, and always it is attractive. Okay, due to their finite masses, the gravitational force is always attractive. This is very very important point. Second one, electromagnetic force. It is a force between the charged particles. It is a force between the charged particles. There are two types of charges in the nature. One is positive charge, another one is negative charge. Suppose if we consider same type of charges like positive, positive or negative, negative, then there is a repulsion between them. Okay, so we observe repulsive force. When it is possible, if we consider same type of charges, positive, positive or negative, negative. Suppose if we consider positive and negative, we observe attractive force. We observe what? Attractive force. Okay, so it is a force between the charged particles. Okay, third one, strong nuclear force. It is a force which holds the nucleons together within the nucleus. It is the strongest force in the nature. This is very very important point. Strong nuclear force is what? Strongest force in the nature. Okay, so how proton and neutron and as well as electron, how they are arranged systematically and they bond with each other. Why they bond with each other? Due to what? Due to the force, and that force is called strong nuclear force. Next, fourth one, weak nuclear force. It is the force between the elementary particles permitted during the decay, beta decay, or we say that elementary particle decay. So that time we observe or we experience this type of force, weak nuclear force. Okay, so it is a fuel, or we can say it is due to the when the sun fusion, I think you might have studied when the fusion and fission reactions are taking place in the sun. So in the fusion we observe this weak nuclear force. Okay, fusion, whatever fusion is taking place, that is nothing but weak nuclear force. Decay of elementary particles or some other like elementary particles like mesons and all. Okay, here I just mentioned the beta decay. So even some other elementary particles, if they decay, then there also we come across, or we study this type of force, that is called weak nuclear force. So these are the two pictures which shows you weak nuclear force. Okay, next one, nature of physical laws. Physics is very vast subject. Okay, physics is a theoretical subject. Physics basically it depends on the principles and the laws, and physics or the various physical phenomena are explained using certain laws. Okay, so totally physics is based on the principles and the laws. These laws are expressed in some physical quantities. Okay, physical quantities means what? Measurable quantities. Okay, so the physical quantities like electric charge, energy, mass, momentum, etc. Okay, suppose if we consider such type of physical quantities in an isolated system, and they are called conserved if there is no external force acts. What is the meaning of that? Isolated system means same. Iso means what? Same. Okay, same system. Okay, if we consider the physical quantities in the same system, they are constant. When they are called constant, if there is no external force acts on them. Okay, then we say that such physical quantities are constant or conserved. Okay, so here there are some important conservation laws. First one, law of conservation of energy. Second one, law of conservation of electric charge. Third one, law of conservation of momentum. Fourth one, law of conservation of mass. So we have to remember these 4 points. Okay, energy is conserved, electric charge is conserved, momentum is conserved, mass is conserved. These 4 physical quantities are conserved. These are physical quantities. Okay, so energy, electric charge, momentum, mass. Okay, so conservation means you might have studied in the school level that we cannot create or destroy some physical quantities. In some book they have given in that way. Of course we are not God, we cannot create or destroy the some physical quantities, but exact meaning of conservation is what? We cannot change. Okay, we cannot change until and unless there is no external force acts on them. That is called what? Conservation. Okay, so this is regarding the conservation of laws. Okay, now it is a time for quiz. Okay, so I have prepared few questions based on the same video. Go through the questions given below. Okay, first one, dash is the strongest force in the nature. Second one, dash is the weakest force in the nature. Third one, dash is the nature of force between two bodies due to their masses. Okay, so pause the video, read the questions carefully and cross check your answers. First answer, strong nuclear force. Of course it is the strongest force in the nature. Second one, gravitational force. It is the weakest force in the nature. Third one, attractive. If we consider the gravitational force, definitely due to their finite masses there is a attractive force, always attractive force. When it comes to electromagnetic force, so we observe both possibilities, attractive and repulsive. But when we study gravitational force, okay, only there is a attractive force due to the what? Due to the finite masses. Due to the finite masses, only attractive force. I hope I have cleared your doubts. Okay, so this completes your first chapter, physical world. If you need further questions and answers from the first chapter, please go through the link given below. This is the link, okay, of the question bank. Suppose if it is difficult for you to reach this link, better you go through this website address. Okay, this is a website, PUC website address. So on home page, question banks are given. Okay, so please click that question bank. You will get a physics question bank chapter wise, and they have splitted the questions according to the weightage. Thank you.